Hi and hello, I am ATHEENAPANDIAN here. In this video, I am going to take something about X-ray relating, because continuously we are watching about the X-ray basics and the X-ray constructions, everything. So in the previous video, I just gave the detailed explanation about characteristics and the behavior of the X-ray. In this video, I am going to talk something about the internal part, that is especially how the X-rays are produced. That is, especially we are going to talk about today is Coolidge tube. Okay, so Coolidge tube is the tube where the X-ray is coming out from the electrons. How the electrons are converting into the X-ray, what happened inside the Coolidge tube, and what is the reason the William Röntgen, who invented X-ray, chose this particular tube. All these things we are going to discuss in this video. So this is the tube called the Coolidge tube. The structure of Coolidge tube is exactly look like this. In all the X-ray machines, maximum 95% of the X-ray manufacturing companies, they are following the tube construction, this particular Coolidge tube only. So wherever the company you are going to place it in radiology, they are used the X-ray tube is called Coolidge tube. Okay, this is the tube where the X-ray is produced. And now I am going to explain about the first point is what is the reason the Röntgen chose this Coolidge tube. Is nothing but Coolidge is the scientist who invented this tube. That is why it is called the Coolidge tube. What is the reason Röntgen chose this tube is this tube having a capability. This is a glass tube actually. This Coolidge tube having a capability to accept almost 4000 degrees Celsius temperature. Up to 4000 degrees Celsius temperature it can able to accept the heat. But the normal glass tubes couldn't able to accept that kind of the heat, right? It will be bursted up. But here, this Coolidge tube can accept 4000 degrees Celsius. That is what this Coolidge tube is preferable. Inside the Coolidge tube, of course, in the introduction part I already told you, inside the Coolidge tube the high vacuum is maintained. That is one more advantage there in the Coolidge tube. Okay, the high vacuum can be maintained inside the Coolidge tube there. Now, I am going to say what are the parts inside the Coolidge tube for the required for the production of X-ray. Two important parts. One is anode, another one is cathode. That's all. Anode and cathode is the two important material that is present inside the high vacuumed Coolidge tube. What actually the cathode is made up of and what actually the anode is made up of. If it is a normal cathode or normal anode or something entirely different or not. I am going to explain you. See, I already told you in the principle when a fast moving electrons is suddenly stopped with a metal target. So the electrons, the fast moving electrons, the electrons initially need to get high velocity. The highly velocitized electron should be stopped immediately. Then only we can get an X-ray. Okay. So anode and cathode is placed in front of each other. Once we are connecting the potential difference between the anode and the cathode, then the electrons are start emitting. Because of high vacuum inside and because of high potential difference between anode and cathode, the normal electron speed is increased. So the electrons, highly speeded electrons immediately coming out from the cathode here. This is the cathode. Highly speeded electrons coming out from the cathode. Within a 1.5 to 3 centimeter difference, anode is placed in front of cathode. So immediately the electrons will be collapsed over in the anode region. During the time the anode emitting some of the rays is called an X-ray. Highly speeded electrons having much amount of temperature. So the anode should having the capability to accept the temperature, high degree temperature. That is what the anode is not a normal ion or normal steel. The anode is completely made up of the special target called metal tungsten target. It having the boiling point and the melting point very high. It having the boiling point range of around 5555, that is 5555 degrees Celsius boiling point it can able to be. And the melting point is around 1514, that is 1514 degrees Celsius melting point it have. So the anode, the tungsten target anode is chosen because of high melting point and high boiling point, because the electrons, high speeded electrons are emitted from the cathode, it produces high amount of temperature. So because of this particular boiling point and melting point, the anode can accept the electrons. Once a collision takes place, all the electrons emitted are reflected as a radiation called X-ray. So this is the point we need to mention about. So this is what the X-ray tube inside happen. So we are connecting the potential difference between the anode and cathode. During the time the cathode start emitting the electrons, because of high potential difference, because of high vacuum, the electrons are moving very fastly and it touch immediately to the anode. Because of the high melting and high boiling pointed metal target, the electrons are touched and it will reflect as a radiation called X-ray. And because of the Coolidge tube is a glass rod, so X-rays are coming out of the Coolidge tube very easily because it is penetrated very easily. X-ray is can't able to penetrate only bones, but apart all these kind of the glass materials can able to easily penetrate it. So the X-ray radiations are coming out, and these radiations are indulged into the patient to find out the internal views. Hope you understand. This is a small introduction about the X-ray tube. In the next video, I am going to talk something about the anode. There are the two different types of anode there. One is stationary anode and rotating anode. What is the reason rotating anode is fixed here, and what are the other possibility there to change? Is there any change required for the anode and cathode? All the things we will discuss in the next video. Thank you very much.